This video on the engineering design process is brought to you by the Cal State Los Angeles ECST Makerspace. I don't know about you, but have you ever wondered how engineers design and build complex systems? After watching this video, you'll be able to describe the engineering design process and the resources at the ECST Makerspace to help you build your ideas and build amazing projects like the ones below. The process engineers use is actually very similar to the well-known process for solving problems generally, where you start by first defining the problem. This includes doing research to fully understand what you're trying to solve. Next, to generate as many different ideas as possible to solve the problem. And once you have a lot of ideas, you evaluate the different ideas and select one to proceed with. You finish by implementing that solution and evaluating if it solved your problem and if you can improve your approach. Next, let's look at the process engineers use to solve their problems. The engineering design process is very similar to the general problem-solving process. However, we often combine the generation and selection of designs into one phase of the process. And then we have a bigger focus on modeling, simulation, prototyping, and testing during the design phase. And we end by implementing the design through building and further improving the design. As engineers, we still do not have the ability to know the right answer beforehand, and as a result, we have to try our best ideas and adjust. This is called iterating, and we do this in each phase and the entire engineering process as a whole. The final blue arrows represent the cyclic nature of the process as we return to the phase that will best help us improve the design after each cycle. In this video, we will demonstrate a real-life application of the engineering design process through our own Cal State LA Baja SAE team, and we will show how you can utilize the Makerspace to implement the design process. Let's begin with the define phase. We will now discuss the details of each phase of the design process, starting with the defining the problem. We begin identifying the high-level objectives of our project. This could be to make the car that has zero emissions or a rocket to reach Mars. Throughout this phase, you will be performing background research on the problem, talking to experts in the area and end users, and reading engineering standards, scientific literature, patents, and other materials. As engineers, we then take our objective and background research and use that information to create specific requirements for our design. Requirements are what our design needs to be able to do in order to achieve the objective. This could include your car weighing less than a target weight or your rocket having a drag coefficient less than the desired target. Requirements are always measurable and must be verified before putting your designs into production and use. Before progressing to the ideate phase of the design process, the design team must present their work to a team of external engineers and managers during what is called the System Requirements Review, to ensure the team has identified all the necessary requirements before progressing. The Baja SAE team is a student-run organization at Cal State LA. Every year, we design and build a new vehicle from the ground up and travel to compete against hundreds of universities at the International Baja SAE competition. Members gain hands-on engineering experience with faculty advisors' guidance, a strong alumni network, and support from our sponsors. Most importantly, the team builds lasting relationships among students, alumni, sponsors, and the Los Angeles community. They also represent the engineering excellence that a diverse group of students can achieve. In Baja, what we do to define the problem is explore all the different avenues that will determine what our designs will become. We usually begin with the rules. Baja SAE every year releases the rules for that year's competition. These rules will have the restrictions and parameters that the vehicle needs to meet in order to compete. Along with the rules, the competition has a set of dynamic events that consist of a hill climb, acceleration, maneuverability, and a 4-hour endurance race. These specific events also define part of the requirements. Once the rules have defined some of the requirements, other requirements are set by team goals. These can include our ideal weight of the vehicle, top speed, our 100-foot and 300-foot acceleration times. We also look back at past vehicles and determine what worked and what didn't work on those vehicles. This further defines the parameters. One other way we define the requirements is to reach out to our alumni network. This group of individuals brings knowledge of the vehicles they built while at Cal State LA, along with industry knowledge to provide suggestions. An essential aspect of our requirements is that they need to be measurable. The only way to know if the vehicle is making progress is by measuring how close we're getting to those requirements. This also keeps us on track and on schedule. Next, we will see how you can use the Makerspace to define the problem.
The Makerspace is a space where students from all majors can go to design, build, and test their projects. This includes projects for personal interests, courses, and student clubs and teams. For the define phase, students in the Makerspace can use the computer labs and talk to experts to perform background research. They can work in teams on whiteboards to outline and review their project requirements. And they can use the meeting and conference rooms to review their design progress with their advisors and industry liaisons before moving into the ideate phase of the design process.
The next step in the engineering process is the ideate phase, where engineers generate as many concepts as possible. They do this by looking at previous designs, talking to experts, looking at patents, and brainstorming as a team. Once a sufficiently large number of concepts are created, then engineers use decision matrices, also known as trade studies, to quantitatively compare their designs. Engineers then use that information to combine concepts or identify areas of improvement for their design. The ideate phase ends in a concept design review to ensure no potential designs were missed and that the evaluation of designs was thorough and complete. Each of these phases are often completed iteratively by going through each step several times, and this is also a hallmark of the engineering design process overall. For the ideate phase in Baja, we take 3 different approaches. The first is ideate based on old ideas. We take components that we have designed in prior seasons, either redesign them for better performance or efficiency, or decide the design is optimized and continue with the same idea. The second option is to modify and combine ideas from other vehicle makers. We often reach out to other vehicle manufacturers to get help with ideas to better our components. These vehicle manufacturers are sometimes industry companies that specialize in off-road vehicles, but more often we go to other Baja teams who share their ideas with the community. The last option is to brainstorm completely new ideas. Sometimes new rules get added and new components have to be created for the vehicle. At that point, new ideas have to be made. A recent change to the rules was to change from 2-wheel drive to 4-wheel drive. This means every team will need to figure out how to get power to the front 2 wheels. Our team explored a hydraulic system, a driveshaft system, and a chain drive system. All of it was new to the team, so absolutely new ideas had to be created. Next, let's see how we can ideate in the Makerspace.
All aspects of the ideate phase can be undertaken at the Makerspace. There are conference rooms and whiteboards to brainstorm, sketch, and share ideas. Engineering literature and successful designs made in previous years offer inspiration to current students and teams. There are experienced students and experts to help you evaluate your design concepts to help you select the best one to enter into the design phase with.
When you think of an engineer, you often think of them doing work in the design phase. You create 3D models of your design with software like SolidWorks and perform analysis and simulation to predict how the design will perform and to ensure that it won't break during use. Because building prototypes and testing are expensive, there is often a review called the preliminary design review to ensure the design is ready for those steps. Once you pass the design review, then you begin to prototype, test, and optimize through adjusting and modifying your prototype. There will be a critical design review to ensure all the requirements from the define phase were addressed and that there are no oversights by the design team before building. In Baja, the team uses computer-aided drafting software to design and visualize our designs. Components usually have multiple iterations. These iterations happen because once the component is analyzed, some modifications might have to be made, or in some situations, completely new designs will have to be made. This analysis portion of the design phase will use force data that the team has collected and use in software like SolidWorks, Altair, or ANSYS to simulate whether the part will pass or fail when those forces are applied. The team also uses MATLAB simulations to determine optimal parameters for those components. There are always trade-offs when designing components. A part might weigh less, but the factor of safety might be lower. To account for these differences, the team creates trade studies comparing the different iterations. The different iterations are then compared using variables that are important to the team. These can be cost, manufacturability, factor of safety, or mass. Once a design is chosen, the final details of the components are finished, and the component is brought into an assembly with the other components in that section. Once that assembly is completed, it can be brought into the assembly of the entire vehicle, where some modifications might need to be made to accommodate for packaging of the entire vehicle. The team then has a design review, where alumni and advisors are brought in to review all the designs. They provide suggestions or corrections that need to be made, and the team then makes the appropriate modifications. The team can then begin making prototypes using 3D printers and other materials like wood or foam. These prototypes can give an insight as to how the components will interact with each other before the designs go into final production.
To perform the design phase in the Makerspace, students have access to a wide variety of digital design tools for students to use, such as SolidWorks for 3D modeling, Altair for strength analysis, ANSYS for fluid simulation software, MATLAB for dynamic simulations, and Mastercam to program automated manufacturing of your design. Students have access to 3D printers and laser cutters to make physical prototypes from various materials of their digital design. Students also have access to materials and supplies for making hand-molded foam and wood prototypes. Using prototypes are less expensive and take up less time and work than machining, giving students a physical model to analyze, test, and redesign if necessary. For electronics, students have access to breadboards, microcontrollers, circuit elements, soldering, and electrical testing equipment.
The final phase is where we build our design. Verify that it meets all the requirements, put the design into use, and track how it performs to identify areas of weakness and strength, and then go back to the phase that will best help us improve our designs and then begin the cycle again. In Baja, this is the phase where our designs come to life. We have spent many months creating these components digitally, and now we can get hands-on experience of building these parts ourselves. This means the team gets a lot of hands-on experience on manual machines and CNC machines. Along with machining, the team also does all the welding on the entire frame of the vehicle. Once the entire build is done, the car can then be taken out and tested. The failures that occur during testing will determine which phase of the engineering process we will have to go back to for that component. The team then takes this vehicle and competes against over 100 top universities in the SAE competition. Here we gather knowledge about our vehicle and competitors' vehicles to begin the new design cycle as soon as the competition ends. Now let's see how we can utilize the Makerspace to build our designs.
The Makerspace offers a wide variety of tools and equipment to build your unique designs. The Makerspace has tools for machining like saws, drills, lathes, and mills. For better accuracy, a CNC mill can machine parts to precise or complicated shapes. Also available is a water jet to cut metal up to 3 inches thick. The Makerspace also offers a wide array of equipment for joining materials through welding, brazing, and soldering. Many hand tools and woodworking tools are also available. The Makerspace team is here to help you learn how to use the equipment and to safely use it. With a little ingenuity and perseverance, there is not much you can't make in the Makerspace.
While we presented a step-by-step process to take when designing your ideas, during the design process, in practice, engineers will always make mistakes, break things, and have to make changes as they go. The design process, each phase within it, and the designs themselves are continually iterated to continuously improve them by making them simpler and better at achieving the project objective.